Hello YouTube, this is Dr. Ronald W. Satz, founder and chair of the International Society of Unified Science and president of TransPower Corporation, a commercial and custom software manufacturing and certified systems engineering company. I work as a theoretical physicist and as a systems and mechanical engineer. As usual with most of my screencasts, I'll be discussing the reciprocal system today, specifically the reciprocal system database. There are two modules to this database, the Microcosmos database and the Macrocosmos database. On display here, you can see the Microcosmos database on the left and the Macrocosmos database on the right. I've already covered the Macrocosmos database in great detail with the screencast from each layout, plus the graphs. And the past few weeks I've been covering the Microcosmos database. I've already covered interatomic distance, valence, specific heat, energy, and entropy. So today we're going to look at thermal expansion. Now, I'm back on the desktop today. I have an i7-990X, which is a fairly fast processor in the system, although it's not as fast as the processor in my Xeon workstation laptop from it's a ThinkPad P72. And I did the last couple screencasts with that, but Screencast-O-Matic doesn't like to work with a 4K display, so I'm back here. So this will just take a little bit longer today to load the screen. So here we go. We click on thermal expansion, and we'll just have to wait for it to come up. You should select the element or compound you want from the interatomic distance screen, which comes up immediately. I'm going to stick with iron for the purposes of this example here. So let's just go back, close, and I'm going to click on thermal expansion. Now at this point, unless you have a super fast Xeon system, you'll have to go get yourself a cup of coffee. I got mine right here and just have to wait for it to load. It will load eventually. Everything works. In the meantime, you can look on the right side, the Macrocosmos database. That module covers the universe as a whole, galaxy clusters and groups, galaxies, star clusters, stars, planets, moons, minor bodies, nebulae, gas and dust, and voids. It also has graphs for the general progression of gravitation and for stars, the properties of stars. So it's very complete. On the Microcosmos database here, this covers solid matter properties, liquid vapor, gas matter properties. So for the solid matter, we have interatomic distance calculations, valence, specific heat, energy and entropy, thermal expansion, which is what we're doing today, compressibility, electrical and magnetic properties, isotopes, and atomic spectra. The liquid vapor and gas matter properties include volume and density, specific heat, energy and entropy, viscosity and surface tension, and electrical and thermal conductivity. It also covers the cosmic elements of subatomic particles, including both material and cosmic subatomic particles, and of course it also covers photon properties. Nice graphing program also with the Microcosmos database module. So I'm just going to sit back and relax while this comes up. You have to understand that the calculations are very, very complicated. It's all ab initio, which means that it all comes from the postulates of the reciprocal system. So all the property calculations you see here for both the Microcosmos and the Macrocosmos come theoretically from the postulates of the reciprocal system. It's a unified general theory of everything. In a lot of cases I use regression equations, which is what up until now engineers had used to calculate the properties of matter. And the book that I use is by Carl Yaws, YAWS, Chemical Properties Handbook. It's very good with the regression equations, but of course it's totally non-theoretical, so you don't really understand what's going on, but you can use the regression equations at least to compare to our theoretical calculations. So just sit back and relax. another sip here. Now the other layouts won't take as long as this. The compressibility won't take too long. And the isotopes layout and atomic spectral layout don't take too long either. And liquid and vapor gas matter properties don't take too long to load either. So it's just the middle three here and the solid matter properties that take the longest time to calculate. Okay, there it is. All right, not too bad. Now the top row here is the same as on the other layouts. The element or compound or mix is given here, in this case iron, Fe. Description, form number, atomic or molecular weight, melting temperature, thermal factors, and compressibility factors. Again, I recommend that you obtain Dewey B. Larson's work, Basic Properties of Matter, to understand these factors here. Of course, the crystal system you would choose from the inner atomic distance screen. In this case, it's cubic, body-centered cubic specifically. So S0 in angstroms is 2.478. And input temperature is here. A lot of times it makes sense to input the temperature on one of the previous screens, like specific heater, before going to this one, because it takes a little bit longer, but it's all right. And then the program will calculate C sub P, which is the constant pressure specific heat, which is really the more important theoretically than C sub V, although I do calculate that. There can be a difference between the molecular and the aggregate values, so keep that in mind. A small difference here, cal per mole per K, joule per mole per K. And of course, it calculates enthalpy at T, which is here, and then enthalpy at the melting temperature, T sub M. And you can see the big difference there. And then, of course, it calculates the volume at T. That's for the cell, obviously. And then the average coefficient of volume expansion from 0 to T, both molecular and the aggregate. Density in grams per cubic centimeters, molecular and aggregate. And entropy, cal per mole per K, molecular and aggregate. And here we have the heat sink and heat source. We go from 0 to 1000. Calculates the enthalpy change here, both molecular and aggregate. Calculates the volume at low T, volume at high T. As I say, it's for the unit cell. Unit crystal cell volume. That's 10 to the minus 24, so you can see how small this is. And then it calculates the average coefficient of volume expansion from low T to high T, which you could use in your engineering work. Density at low T is here, density at high T is here. So, I do duplicate the data from some of these previous screens here just for convenience, so you don't have to keep hopping back and forth between the screens. Here's the C sub V calculation. Here's the internal pressure calculation in dynes per centimeter cubed, or squared, excuse me. Initial compressibility is important. The ratio of C sub P to C sub V, aggregate, a little different. The Guneason constant, molecular and aggregate. And then I threw in a couple other properties here. Speed of sound in meters per second for longitudinal rod, longitudinal bulk. So that's interesting. And it transfers speed in transverse bulk solid. All right, wow. Now, the items you see here in the boxes, that's where you input. Now here, this really comes from the inner atomic distance layout, but here These three things are what you would change if you wanted to get different values. All right, well, that's it for today. I'm going to close out. I've already covered the items here on the Microcosmos database module and the Macrocosmos database module, so I'll just mention my theoretical physics mentor, Dewey Larson, was also a theoretical economist, and I've made his work in economics also fully computational, just like I've made his work in theoretical physics fully computational. Now, my work in theoretical physics that I have that gives all the background for the two database modules is my work, Existence and Interactions, a Computational Treatise of the Reciprocal System, the True Theory of Everything. It's a software ebook, 711 pages in the PDF file, 711 slides in the PowerPoint file, thousands and thousands of equations, diagrams, figures, tables, you name it, it's in there. It'll take you months to go through it. It has all the math you need. Now, if you really don't want the math, if you just want a simple introduction to the theory, get my work, The Mysterious Universe. I wrote it many, many years ago, but it's still in print, still selling very well, actually. The Mysterious Universe has all the concepts, contains a critique of conventional theory, and then it goes through the reciprocal system step by step so you can understand it. So if you're new to the theory, you might want to start with the Mysterious Universe, then get Existence and Interactions, and then after that get these two database modules, and then you'll be in good shape to apply the theory to your scientific and engineering work. As economics goes, I have Optimal Economist, Larsonian Econophysics, which an implementation of Larsonian Econophysics, and it explains the microeconomics of individuals, businesses, and business sectors, and macroeconomics of countries and regions. So it's all computational. It's quite amazing. We'll get to it eventually in my screencasts. I've recently reduced the prices of most of my commercial software all the way down to $95. So these two modules here are each $95, and the Optimal Economist is also $95. Existence Interactions is $33, and The Mysterious Universe is a mere $9.50. So I sell one of those, it just pays for lunch, basically. We provide free phone support and email support to anybody using the system. Of course, any bug fixes are free. You can always go to our Dropbox site to see if there are any new additions. Pretty rare that I have to change anything. All right, well, that wraps it up for today. Please study the reciprocal system and prove it for yourself. And thanks for your attention.